So we have this equation that root of x plus root of y equals to root of 27, and we have x and y as integers, and x and y are greater than 0, so means these are positive integers. And we have to find all the possible order pairs that satisfy this equation. So one can do this in mind by just guessing the possible order pair that satisfy this equation, but that's not a good way, because you may have some greater number over here in place of 27, and then it will be difficult for you to directly guess the possible order pair or the possible values of x and y. So let's start this equation, and let me write this equation again. Over here we have root of x plus root of y equals to root of 27. Now I can square this equation to get rid of this square root, but before that let me move this root of y to the right hand side, and we have root of x equals to root of 27 minus root of y. Now squaring the equation, we get x equals to 27 plus y minus 2 times root of y root of 27, and then simplifying we have x equals to 27 plus y minus 2. Now we have 27 as 3 cube, so we can move 3 out of the square root, and we have 2 times 3 6, and then root of 3y. Now what? We have x as a positive integer and y as a positive integer, so it means that root of 3y is an integer. Why I'm saying that? Because the sum of two integers is an integer, and then to have an integer we have to subtract some integer from an integer, because the sum of two integers is an integer and the difference of two integers is an integer. So root of 3y is an integer, or we can say that root of 3y is equals to some number m, let's say, and m is an integer, or from this we can say that 3y equals to m square, or y equals to m square over 3. So we have found the value of y in terms of m. Similarly we can do for x. Now using this equation again, we have root of x plus root of y equals to root of 27. Now moving x to the right hand side and then simplifying, if we move x to the right hand side and then square the equation, at final we get y equals to 27 plus x minus 6 times root of 3x. And from this we can say that root of 3x is an integer. And if this is an integer and let's say n is that number, then we have 3x equals to n square and x equals to n square over 3. Now putting these values of x and y in this equation, we get n square over 3 root plus m square over 3 root equals to 27 root, and simplifying we have n plus m over root 3 equals to root 27, or n plus m equals to 3 cube and then 3 to the 4, we have 9. So n plus m equals to 9, and now all the possibilities are that n is 1 and m is 8, n is 2, m is 7, n is 3, m is 6, this is 4, and this one is 5, and then 5, 4, 6, 3, 7, 2, and 8, 1. So we have 8 different values of n and 8 different values of m. Now putting these values in these equations to get y and x, we have y. First let's solve for x. So x equals to n square over 3. Now putting these values in this equation, we can have 1 over 3 and 4 over 3 and 9 over 3 and 16 over 3 and then 25 over 3 and 36 over 3 and then 49 over 3 and then 64 over 3. But these values gives us fractions, so we have only two possible values of x, and these are 3 and 3 1 and 3 2, 12, 3 and 12. We have these two possible values of x. Because x is a positive integer, so it cannot be a fraction. So we have x equals to 3 and x equals to 12. And similarly we have y equals to 3 and y equals to 12. Now if x equals to 3, then y equals to 12, and if x equals to 12, then y equals to 3. So we have two possible order pairs. One is 3 and 12 and the another is 12 and 3. Thanks for watching and subscribe to my channel.